Thank you for attending today's webinar. We are going to discuss about very fantastic topic, AI-enabled quantum applications driving real-world value. So, um, I'm going to talk about just introduction section. So, state-of-art real-world quantum application, and so it's some introduction, and then we have an industry expert to share their insight. And some of the speakers like have some conflict with their flight schedule or something like that. So I'm not sure whether they will attend today, but definitely Lagur, she's the CEO of RQS Quantum and then Asia Pacific Grid Quantum Business Network. He attended and then he will definitely talk. So after my talk, and then if the I will wait until the last time about if there is a conflict with the schedule. But anyway, so Lagu will be share is his like insight about in a view of the East Asian side viewpoint. And then if time allow, then I will show the live demo about what is meant by the quantum application. So you will see the industry-wise live demo. So you will see that what sense of the what is meant by the quantum application in the current state of art. And then we have a maybe Passover. If time Passover more than one, and maybe have a short time of the like a Q&A and open discussion. And during the time you can share the question or comment using chat box. Okay. Okay, I will start my introduction first, and then we'll start. Okay. So let's see. Just waiting to let us. Okay. Okay. So to understand application, actually, the we need to understand infrastructure, right? Because we are based on quantum computing, right? So here is my summary. So I just tried my best, the current state of art, the quantum computing hardware ecosystem. So if you are in a quantum ecosystem, you have several type of the good news about actually the different modality and vendors launching their quantum computing to use by other people in a like a standalone or in a like cloud service like Amazon. So basically, the current state of art, I can just group them by their modality. So the quantum computing have a different type of the technology space. So first is the superconducting. This is like most people know and well known, right? It's based on superconducting. So it's basically IBM Quantum, like well known. Like it's very famous. Google Quantum AI and Ligeti, and then IQM, Quantware, Securus, Atlantic Quantum, and many others. So this is the fast gate operation, usually called gate-based quantum. So because of when you do some application, actually, you know about the characteristics of this hardware, like whether they fit into some specific application. So this they call at the time is a gate-based operation is means to something to the application and trapped ion. So this is recently there was IPO in this space, IonQ, Quantinum, you may is a recent IPO, and other Oxford Ionics and AQT and others. So this is like the highest gate ability all-to-all connectivity. Okay? And neural atom also is very founded in the universal research. And for example, Cura, they're based in Boston, like me, and then they're the founding members are from the Harvard and MIT, and also like Autumn Computing, Pascal, and then Infraction is the some of the example. So the primary strength is a massive qubit scalability, and then photonic, and this is single photons. So psi, quantum, and Xanadu, and other kind of things that you can learn about. Like the Xanadu is also very famous in this space, and psi quantum is a very also like very active. And then you can think about the silicon spin, right? The silicon spin, usually Dirac and quantum motion, and particularly in the big semiconductor device manufacturer Intel. And diamond, this is a quantum brilliance is relatively new, so you can think about it as maturity, right? Because all of this is more mature, and this is emerging. And also like photonics is the rarer space, and cat cubic bosonic is Alice and Bob is one of the famous startup, and topological is a very early stage, but is supported by the Microsoft Quantum. And then best well known, but this is a very special type, right? Because this, even if it is well known, is they are based on quantum annealing. So it is not the general purpose gate based, like a superconducting and trapped ion is a general purpose. Is quantum, this kind of DA and other the in this space, actually the specific targeting quantum application usually optimization. So there is something different, and electron and helium is LQ. So once you understand the current like the ecosystem of quantum hardware, then you can think about what kind of like the purpose of this one, real application, right? Because you can think of traditional computing, right? The computing is the infrastructure to attack a lot of the real life problem, scientific, engineering, and industrial and science and other things, right? So research. So this is basically the current state of art. And for if you are not just the application, if you are interested in the hardware based like infrastructure, usually they are not just a hardware, they are a system. And then, and especially there was the global initiative about the fully functioning. The fully functioning means that the fault tolerance quantum computing is recently the EOD, United States and other countries launching the multi-year initiative to develop this fault tolerance quantum computing. So the next week we're going to have this webinar. So if you're interested, you can attend. Okay, so application landscape. So there are many, right? But I've just provided four only representative in here. So they are based on roughly the mathematical models. So MIF is one of the famous uh, optimization, and then many other things like quantum simulation or quantum machine learning, where the cryptography and security is full fair. And then rapid quantum algorithm computational paradigm is a quantum learning, as I mentioned about it. And then other things you can look at it, right? So you can when you think about the specification, then you can think about the what kind of like application you want to do and what kind of mathematical model you are going to attach. And so let's look at what the current state about the real world quantum application pilot, right? So it's not fully deployed as industry wise as fully commercial. So the current state is a pilot stage, like looking through the like availability of the quantum application in different industry or different subject matter sectors. And also they are looking for some like the potential of the quantum advantage. So means that the quantum advantage means many different things. One is they are quantum native, means that the industry or the scientific problem in nature they are more better fit into quantum. Like for example, their underlying physics is operated by the like quantum computer, right? Quantum computing, like such as like quantum mechanics, Schrödinger equation, or something like that, right? And other is to like a complexity of the problem, right? To naturally put into more like a degree of freedom in a quantum computers compared to the traditional like a binary computer. So they have another advantage of the by the nature of the problem and other many other things you can think about that utilizing quantum. So another maybe the security, right? Because traditional security is not like safe under the quantum computer. They can be encrypted, decrypted. The mechanism is completely different and much powerful. So you can talk about that way. Okay, so in healthcare life sciences, drug discovery is most fascinating. I also intensively tried this space before, and then I have several. I organized maybe more than 5 times about this topic in the webinar. So I invite the speakers and talk about it. So you can think about this is the most active, and then as far as my understanding that many kind of like a big pharmaceutical company operating their quantum specialized team. So they hire quantum specialists to do this explore, but still very research and all these days. So, so you can heard about the IBM Cleveland Clinic and done and other like a big pharma like a Roche, AstraZeneca, Merck, and other they are trying to do. And there's also like a biomolecular simulation is a quantum chemistry. They call quantum chemistry area is a part of the quantum biology or the quantum drug discovery. It is a very active area. So and another area is that I will show you today something that related to genomics, like precision medicine space that they are also very active. And then I also have I have some strength advisor, some startup actually. What they're doing is a AI, like a clinical trial space utilizing agentic AI and the so-called physics informed AI. So I'm very familiar with this field. And then I also try the end-to-end clinical trial optimization using quantum. So this field is very active and biomedical AI X-ray. So I think the most promising field is healthcare life science, and actually I had intensive experience developing some new like business cases for this space. And financial service is particularly very strong because of the nature of these financial services. So portfolio optimization is a huge amount of the like portfolio is operated by the for the investment firm and asset management firm, and they also have a one webinar about this topic. So I showed how to do in the portfolio dynamic portfolio optimization. So if you're interested, you can look at my recording of my previous webinar about this topic. And if time allowed, then I show today. And algorithm trading market making is one of the like a trading and investment side and risk analysis and treasury liquidity optimization. Especially I have experienced for the apply to they call the digital asset cryptocurrency. So this is was also very interesting topic. And also recently there were a lot of the the trials and there are people are interested. I saw that there are several people already have a webinar about this fraud detection. And particularly that this sector is very, very interesting post-quantum financial security. So it's like a quantum safe because of this financial sector. And then we know that we set the Q date about like well the quantum post-quantum like security should be adopted by the time. So you see that here is a reference organization is a shoes like a big like a bank, investment bank, and an asset management company working in this space. Okay. Okay. So and then I'll share my presentation. So I will skim over many things because of time limitation. But anyway, because I did show that we have already have quantum is not not like a fantastic technology to explore in the early stage. When we already applying the developing quantum to the real life application. So energy sector and utility sector is one of the another sector that for example EON Europe the largest the electric company, and then working with IBM and other big company, also like national level companies and electric company in the United States. They all are interested in this space because of the in this is a very complex environment. So they want to solve the very complex situation like a power grid optimization, and renewable energy integration, and many other things. Like electric vehicle is one of the topic. And also because of my plan is actually that I'm attacking one of the problem actually the EON now looking for in the like grid optimization that whether you want to like a power line like investment or not, and then whether you decide whether the this kind of optimized to be like ROI proof, and then it can be like a valuable to invest or not. And then actually that they provide as a proposal now, and then due date is September 15th. So I try to solve this problem, and then up to now I have been halfway. I didn't actually. I hopefully I solved it. I tried to present today, but unfortunately I didn't. I was in the halfway. So once I then I maybe show you. And other sector that is the supply chain logistics smart mobility. This one was I did one time of the webinar of this topic. So this is also very like energy sector, like network of the different like entities and different components. So complex situation. So supply chain network optimization is one of the thing, and logistics. And this one is kind of like a future, like very promising. And then recently there was like a automotive company, a Volkswagen and Toyota, and they have their own like research institute about this one with integration with other vendors. And then manufacturing industry engineering is one of the factors like smart industry, smart manufacturing, so this space. And climate change sustainability. Oh, this is one thing. So I have a lot of the opportunity to contact with the people in the space, and then particularly climate system modeling, risk management, and energy transition optimization is very good. And sustainable supply chain optimization. And advanced material chemical is one of the strong candidate to apply quantum. And also telecommunication is very interesting thing that I have expertise. I originally from South Korea. When I was South Korea, I was in telecommunications, so I know about this field very well. So especially they want to be quantum secured, like their network security, and also they're under 60, like a standardization, and 5 is a final stage. So they want to apply this quantum in the network optimization, and other stuff, and also like they have interest in the distributed like quantum security. Okay, and then what I learned from this, right? So different industry often solve similar mathematical problem, right? So I was looking for the unified scheme of how to solve the problem utilizing quantum, even if a different industry, different type of the problem, but they will result in the different is often is they're the similar mathematical problem. And then no single quantum hardware modality is universally superior. Right? This is so we need to have opportunity to explore the different type of the modality to have a best answer. That's one also I am working now in the different testing the different problem over the different modality. And AI is a killer. That's why that in the future that AI will be embedded in the quantum by nature. So I just use a term AI nature quantum computing. And then classical HPC is remaining this, so they call hybrid quantum. So the classical quantum, quantum plus in the hybrid way to the traditional quantum computing uses will be in the keep going on. And others like business values create a value to decision, not quantum speed alone, right? Because validate decision making to how to solve the problem is the key. And so, So AI quantum computing means that the problem should be mapped into mathematical paper hardware, mathematical model determining computation strategy, AI orchestration model, crash HPC, hard quantum, and the future computing advantage will come from decision intelligence. This is actually the I developing the framework. So this is one framework I wanna be the unified, that's I mean the unified way to in even if it's a different industry, different subject matters to have a unified scheme that best way to solve the problem utilizing quantum hardware through some intelligent decision making workflow. This is one actually that I'm developing. Okay, so I will stop here. Okay, then next here. He's I think that we didn't met personally before actually, but I because I'm very active in LinkedIn, and then I found that there he is, and his company looks like very active. That's why that I invite him to. He might be the best person to share his real world application
Mm.
of quantum. Here, can you share your
Hi.
insight?
Hi. Could you hear me?
Yeah.
Hi. Alex, I'm very honored to you to invite this webinar, which is excellent. I appreciate. Thank you so much. Okay. 20 minutes, the explanation, or 15 minutes?
Oh, whatever you can,
Okay.
because
Okay.
everybody
So,
will be interested in hear from you, right? Nobody
yeah.
bothered by the time, right?
Okay. Yeah. Everyone, could you see my
Yeah,
screen?
yeah, yeah.
Hi. Okay, again, so I'm very honored to join this webinar. So we are leading the application developments in any industries to adapt the real business world. So my topic is pretty much fits on this webinar topic. Thank you so much. Okay. So before going to that, so let me introduce briefly myself. So JJ is the quantum slash optimization startups, and I'm CEO and the board member of the JJ. Also, I contribute to the activity of the World Economic Forum's and activity. Also, I'm the board member of the QSA. QSA is the Japanese Quantum Industry Consortium, and I live in the London, the UK. So I try to behave as a bridge between the Japan and the UK. And then finally, we are also the member of the QE, QE, the European and the Quantum Consortium. I'm the steering committee member of their annual summit. So anyways, I'd like to contribute the bridge in the world. And so JJ's mission is making society computable, contributing to the advanced humanity. And we have the many industrial problem is solved. And also we are focusing both the mathematical optimization and quantum computing. And we have the office in Japan and Germany and the UK, and we established our US branch in the last July. So optimization and the quantum, first point is that we have many stakeholders. This is our one of the stakeholder map. So first is a company. The second is a research lab and institution. And third one is academia. In the company, still there are so many stakeholders. So number 11 and 12 is like operator. They doesn't care what is the physics and math. They doesn't care the quantum and optimization. And then 13 is like a data scientist. And then data business integrator. So they start to care between the real operation and then data and the quantum optimization. And then business team has like a business development persons who connecting business and operation. Also in the research lab, researcher and research manager, academia, professor, postdoc researcher, and administrator. They have so many different motivation. And then we provide mainly two different part of the solution. First one is the OptoX. We provide a real business software to the company. And also, we provide a developer platform called JZ, which is to adapt to writing the mathematical model and then deploy the model. Plus, we connect into the quantum hardware. This is what we provide through the JZ. And this shows the bit complicated, but it's their developers' experience of the optimization from the 1 to 30. So it's composed of 4 parts. First is the project preparation, next is the project definition, third one is modeling, and last one is deployment analysis. In these 30 items, if we're talking about like a quantum algorithm or quantum hardware development, it's just only like 18 or 20 just here. But through the total optimization developer experience, we need to do a lot. For example, we need to collect the real data. We need to define what is our goal, what is our KPI. Also, we need to making the mathematical model, and then we need to analyze what the output through the hardware. So through this developer experience, we need to take care of just not only using the quantum algorithm, the quantum hardware. And we experienced over 60 optimization projects: energy, telecoms, manufacturing, space, bio, railway, transport, construction, and materials. So this is an example in the UK. UK has the 10 years national quantum strategy. And one of the use case development, JAJ led the project with the BP, one of the biggest energy company in the UK. Also, Orca Computing, they are photonic quantum computers hardware company. And then hosting is by NQCC, National Quantum Compute Center. And then we wrote the white paper together. So this project is called the Unit Commitment Problem, which is a large-scale type of problem. It's very difficult to just adapt to the hardware to the single the problem. What we try to do that is split the problem to adapt the proper hardware. So this shows how to decompose this total unit commitment problem. And so this is the business opportunity in the one company. So this shows if the one company is from upstream to downstream, they have the portfolio like E&P, transportation, storage, power plant, transmission, and then using the city and industries. Once they achieve the success of the one problem, in this case, the unit commitment problem, so they can adapt the other problem vertically. Also, they can adapt to the other problem in the horizontally, which means that the optimization has a lot of the business opportunity horizontally and vertically. And then what our product try to it's like a platform to support not only just only one problem. Also, we support to the total optimization problem. So this platform collecting all data, and then from operator to physics and mathematician, we connect their knowledge from the GNT AI. This is what we do through the JZ. The other use case is that the production planning. So their challenge is that they have over 100 product types. It's a huge amount of time they spend to making the planning. But if they start to using a platform, including the optimization algorithm, they can reduce their calculation time to the 6 hours to the 1 minute, which is a huge reduction of their calculation cost. Yeah. This is also in the manufacturing company, not only the one division, but also the other division, the other product, they have the opportunity. Once they success this opportunity, they transfer to their knowledge in the other the factories. Also, they can adapt to the other process and the other division. So which means that in the manufacturing company also has the many business opportunity upsell and cross-sell. And our platform support their total optimization calculation projects. Yeah, so this is the other example is SoftBank, one of the biggest telecom company in Japan. So they have a challenge for the wireless networking, and we try to use the carrier aggregation, the calculation, and then we can achieve to reduce the download speed. Also, we can increase the data traffic. This is our output here. So the other the use case is that called the JR Toka. It's the one biggest the Japanese railway company. So this is when they make the annual planning of the railway. So the railway line is pretty much complicated. Also, the crew allocation is also very complicated. So they use our platform, and then they can reduce their labor cost and wasting the train's time. Yeah. So the last one is that the typhoon calculation is in the Taiwan and Japan, so many typhoons. So we try to adapt the quantum algorithm to reduce their calculation data. This is what we tried to do. Yeah. So anyway, so in the optimization, as Alex said, there's a lot of the use case opportunity. And then not only us, but also in the world, we start to adapt just not only R&D project to the real business use cases. Yeah, this is our trend. Yeah. Thank you, Alex.
Thank you, Hiro. Yeah, fantastic. Wow. You did a lot.
Thank you.
Okay, so I think that you are the one of the pioneer to make quantum at the mainstream.
Thank you.
Yeah. Okay, so we'll have a separate Q&A at the end. So we'll continue the industry expert like you. Could you share your insight?
Of course. All right. Hello, everyone. My name is Raghu Raghunath Kodavayur. I was just going through the participants list, and there are many friends and familiar faces, which is the case with quantum. So, pleasure to be here. I think we'll take a different approach, slightly different approach, and focus on the quantum inspired intelligence. My background is I used to sell quantum computers, full stack quantum computers. I was with IQM Quantum Computers, part of the leadership team there, moved to Singapore to expand market expansion of IQM, grow, enter into the APAC market, established IQM here before founding Rax Quantum. So it's a journey where I do understand the challenges of selling the full stack system, and I've sold quite a few in the world. And then before starting Rax Quantum, because I saw the opportunity on enterprise adoption. So when Alex invited us for this session with the enterprise application, it's a sweet spot and everyday life, at least in the way we discuss with enterprises. So we solve challenges of AI. We took an approach saying, yes, quantum algorithms are important. Quantum algorithms today are important to invest in, but the output might not be a real quantum use case or real ROI. So most of the enterprises start asking the question, and many of you might question saying, what is the ROI or why should I invest today? To investing today is preparing for the future. Very, very important. But then we said, can we also help you get immediate ROI? And this is where the quantum inspired intelligence comes in. So what are the challenges of AI that enterprises ask us? Most likely, the most of the times the question that comes up is rising token costs. So I speak to banks, marine industry, logistics every day, and the question that comes up is, Raghu, our token costs are going high. The second one, which comes up even more, is energy consumption, especially in this part of the world. And the third one is privacy, because of all the computing happening on the cloud, there's a lot of discussions around privacy also that comes in, maybe latency to a smaller extent. So these are the challenges that enterprises already see today with AI. So we said, is there a way we can address some of them with an approach? So we came together. So we are founded by company, like this company is founded by founders who have built quantum computers. So one of my co-founders has built three quantum systems in Singapore. Anyone who visits can see these quantum systems. My other co-founder is a guru in quantum inspired algorithms and quantum algorithms. And as I said, I was also involved in the growth of IQM's business. So we came together to say, okay, what is it that we can do today and what can we do in the future? So basically, in the short term, how do we answer the question of enterprise ROI, which is important research, but also is there a business result that we can deliver? So we chose a approach of tensor networks, which I think some of you, again, looking at the profiles of the participants, I think physics background, or if you're already following, let's say, mathematics, you know that tensor networks are mathematical tools to represent quantum systems. Now, what if, today, with the challenges that we have with the GPU availability and also the LLMs, which become very resource intensive, the argument that comes up with this quantum inspired world is, can we use tensor networks for computation? And what kind of a use cases can we use them for? So if you read the latest Deloitte report from June 2026, Deloitte has mentioned a key point which I really like. This quantum inspired can bring tangible business value today while preparing enterprises for the future. And the second important one is the more LLMs demand the hardware, then you also see that there's a lot more demand for edge computing and edge AI. And Gartner report from March is also very interesting, where they say over two-thirds of computing will happen on edge AI from 10% in 2025. So there's a significant, right, where we are talking about 5x growth on edge AI. So you need smaller or compressed LLMs to run on edge. So these are the opportunities that we saw, and we build on it on tensor networks. So our solution, we have a tensorization platform where you put the classical data or classical LLMs, and then we automatically compress them and then make it into tensorized. So tensorization is one solution that we have, which is more of a platform approach for customers. While we are also investing in the R&D of digital, or say ASICs approach of processor. So starting with FPGA, then with the application specific processor, combining this tensor network as well as processing power. So it's a chip that we are also working on. And then we have some services, which is what mainly pays or generates revenue today, while we continue to build the market for the automation platform. So how we work with enterprises, and then I'll go into some use cases. So like any other innovation process, right? If you have worked on cloud transformation or digital transformation, it starts with defining and planning. In this case, we work with classical AI, and we start with the overall quantum strategy. We ensure that the problem is right, where there is a need for quantum or there is a need for quantum inspired. If either of them is no, then we tell the customers that maybe right now you don't need quantum, you might need only classical solution. So this is a fair and honest effort that we make in the step one to ensure that the customer's expectations is managed well. The second one is where we do the POCs and then the actual proof of concept projects. Here we work on the quantum inspired, as said, with the RAX tensor. We do the tensorization, which can then be used for optimization problems, compression needs, and also anything else that we want to do with them. And lastly, we are then creating a roadmap for them, where some of the enterprises can also set up their own center of excellence, or they can also work with us on quantum algorithms or with our partners and so on. So we ensure that it's a three-pronged process with the current state, with a near term. The near term, the second step can take anywhere between 3 to 6 months. So we give tangible results to the customers in 3 to 6 months using the tensorization platform. At a minimum, you will save your token costs. So that is with the compression. And that gives the confidence for the customers to invest more into the quantum inspired algorithms. And then we move forward from there. I'm not naming the customers here because I think most of the use cases you would hear is almost similar, and many of you would have read through them. But I'll tell you how we chose customers and why Asia Pacific is different. Because APAC is the way of doing business in Asia is different. The way ROI is measured in Asia is different. And also from the Western world, especially most of the audience who are based in the US or in the Western, like Europe, I think there is a stronger R&D mindset in in those markets because organizations invest into longer term R&D. In Asia, what we have noticed is that customers want shorter term results, and that is where the tensorization platform becomes very relevant for them. And we have chosen also industries which are highly relevant for these markets because as a continent, Asia is one continent, but then there are individual markets with different ways of working and also different challenges. So we are focused on logistics and supply chain as our first market where we see a lot of optimization problems that we can solve. For example, one where we are working with a Southeast Asian country and we are proposing and we are working with them in some way is connecting the multimodal transport. Can we connect a airway with a waterway with a road and a rail? And can we optimize logistics around all of them? Instead of only optimizing logistics on a roadway or a railway, which would be a classical optimization challenge, maybe, because then you get compared, right? Classical AI can already do that. What is so special about you? So we are trying to solve a problem where the problem statement is so big at a macro level that it connects all forms of transport. And then can we optimize the logistics so that there's no wait time between a rail delivery to shipping onto a ship or onto a road or anything else. So that is one of the use cases where we are working on with this approach. The second one is manufacturing. Third is maritime, where port operations, where we are working on right now. Then BFSI, here we are working on multiple use cases on fraud detection, anomaly detection, then on compression, data compression, and then optimization. And on the energy, more we are proposing in terms of the grid optimization. So all of these industries like us because we compress the data and then we help them save some tokens, costs or expenses, so which is the ROI near term. And then on a longer term, we are or midterm, we are working with the quantum inspired algorithms, preparing them for the quantum algorithms. Yes, so as you can see, the use cases optimization, anomaly detection, data and LLM compression, and finally, Edge AI. So this is still in early stage R&D for us. We are still a 18-month-old startup, so 1.5 year old. So here we are working as part making our tensor algorithms or tensor networks architecture onto a hardware. And this we have proposed to a couple of customers, mainly on the hospitality and one large casino in the region. And we are trying to see if we can work with them on increasing revenue per square feet of the property. We also have noticed one important challenge is most of the customers ask us, what is quantum? So, and that is a big question, right? And why should I get into quantum? So there's been a lot of education. So we have also monetized it. So we have a certification program with Singapore University of Technology and Design Academy. So if we train people, they get SUTD Academy certification and also a Joint Racks Quantum certification. In Singapore, it's also public funded. So government subsidizes 70% to 90% of the fees for this upskilling program. So any computer engineer or AI engineer can actually get trained on this. We have conducted these sessions now in Singapore as well as in Dubai. In October, we are also conducting one session in Abu Dhabi. And this has been very popular. So we have trained over 75 engineers on quantum AI certified with a Singapore University certification. So which is very at least as a found real good product market fit. The other one on the education where we got invited for many board meetings and CXO meetings is a 1.5 hour, 2 hours of masterclass on quantum and what should be the quantum strategy for enterprises. So we again said we don't want to do it for free. So we monetized it. So now quite a few of the board teams, at least in this part of the world, and also leadership teams invite us for this 2 hour session which we call it as CXO's masterclass. And then they also pay us for that. And we have also certified through this program about 75 CXOs. So 75 CXOs and 75 engineers at least been trained over the last, say, 1.5 year time. This is where we see the opportunity to upskill the current workforce, answer the questions of what is quantum, why quantum, how to invest in quantum, how to get started in quantum. Then we take them through the journey which I mentioned, which is on define and plan, prepare and invest, and then quantum advantage later. We are also the founding members of QBN Asia Pacific, which is an ecosystem, again, similar to other ecosystems. So QBN is very popular, Quantum Business Network in Europe. They have over 120 already paying customers and startups, quantum companies members. So we took the same network to Asia. Now in Asia, we already have about 10 to 12 companies already paying members, and then we are growing this ecosystem. And we position the QBN positions itself as the bridge between Asia and Europe. Europe has access to talent, Europe has access to R&D funding, and also a lot of technology, while Asia has opportunity with businesses, real problems, and also capital, and we connect these two. So although Rax Quantum does primarily our quantum inspired intelligence, we have seen that education and also this ecosystem building is very important because quantum is still in the early days, and that's where we have seen our role to build this kind of an ecosystem. So in summary, Rax Quantum brings together Tensor Network, Edge AI, and also quantum expertise with deep APAC market understanding, Asia market understanding, which is very important to deliver real enterprise value. So our solutions span different industries. But if you are a technology leader, if you are a quantum company, if you are an investor looking to expand in APAC, then let's connect. This is my coordinates, and then I give it back to Alex.
Thank you, Al. Yeah, fantastic. Yeah, you did a lot of the activities. And particularly, I'm interested in you that education, right? Because
Yes.
like I have for the past several months, actually, I did a similar thing to invite a lot of the stakeholders, end user stakeholders. So usually they don't know about any previous knowledge of the quantum.
Yeah.
But actually, I try to promote some of the actually the platform. I'm going to show you some demo today.
Mhm, mhm,
The company actually I have a business partnership. I have them to developing the product and also their promotion to the reaching to the end user. My experience over 4 months, I contacted about 3,000, more than 3,000 end user level stakeholders. Like for example, the in the we I try to promote using the like a webinar topic was a quantum AI native quantum driven logistics supply chain. That means I try to invite the people from the like as you did like a top executive in a like a logistics company like DHL, right, or the supply chain management company or the consulting company. Actually, I successfully connected. I have invite about the 200 in the field. I feel that like Amazon logistics and other kind of logistics supply chain, but they are nothing to do with any quantum, right? They are tech share because they utilizing AI and other technology to make their business advance, right? So my initial expectation is they may be interesting in the new mechanism, quantum, right?
mhm,
I try to sell it can be value created,
mhm,
right? And this I have naively I just if I invite them and then like introduce very fantastic like business kind of like enabler, they're willing to do job.
mhm, mhm,
But I provide my white paper. I invited several times. Only few attended, and then I have posted things. I just even I posted a lot in their group, like LinkedIn group or Facebook group about why this quantum application is fantastic, how they bring the real life value like we did today. Difficult.
But
I
maybe,
found.
maybe I'll tell you a different way to approach it, Alex. It has worked exceptionally well for us, as I've shown with the numbers, right? So we do get invited for many of these training, which is paid training, and we
Mhm.
don't do any advertising ourselves. So there's zero spend or zero activation from our side because we do not want to sell that as a service. It's a byproduct we see as an opportunity. The good part is, I think it's a change management project. So you need to think of it like the old school digital transformation or IBM's the solution selling transformation many years ago, or you need to think of it like cloud transformation, or now recently the AI transformation. So it has to be coming from the top down. It has to be a information officer or a COO or a CIO or a CTO's mandate. So if you go through that top down, that the organization needs to be ready, then you will get the buy-in. But
I
if you go
see.
bottom up, if we try to get individuals on board, individuals will join webinars, they would like that and so on, but they cannot have the influence to get the organization to change. And quantum is a topic where you will need your own center of excellence, or you will need to immediately go and do proof of concept. So I think what we have found a sweet spot is we don't just get the buy-in from the top down, but we also then have the
Oh,
resources. I have about 30 quantum scientists who can go and do the POCs with quantum inspired tomorrow and deliver
uh-huh.
results within 3 to 6 months.
Oh, I think that I want to collaborate with you because one topic actually I found very interesting and very valuable, but actually I defer my webinar several times because I didn't get enough like interest from the field. That's AI data center operation optimization, especially the energy optimization. I found that I simulate that space really fantastic and then is a timely topic, right? Because the energy, like a sustainable energy in the operation wise, because the key, like a bottleneck of the huge data center operation is energy, right? You know that, right? Because there are a lot of like a small module type, the nuclear power plant building for the sun specific. So data center. So data center AI data center in the key for the future industry development, right? But actually, at the same time, we are not at the right like a technology can bring that optimize their operation. So I found that that's a good opportunity, right? So I wrote a very good article and they share the community and then invite people. I just try to connect more than 100. They are related to like energy management in the data center, and then but I only recruit about dozen. They express they attend.
But
And
maybe
then I try to individually connect, for example, at some of the data center like a developer, but I cannot persuade them.
can I give a different perspective, because we also work with many data centers right now.
Hmm.
We don't have them as customers, but there are very advanced discussions that we are part of. The thing is, data centers do not, yes, you are right, the energy is very important, but they cannot optimize it, and maybe quantum is too, like it's not needed. Quantum is not needed to optimize the energy within a data center. But what data centers are very interested, the kind of data centers we are talking to is an extra revenue stream, a value added stream for the customers in data compression without any accuracy loss. So most of the data centers we speak to, they have now we are in the second, third, fourth level proposals and meetings, is because they see the value there. If you really want to optimize energy, then you need to look at quantum data centers, where data center installing a quantum computer to maybe give more power. But most of the data centers in the world that I have spoken to, they run like a pure real estate company. So they do not like investing into innovation unless their vision is a quantum data center
I see.
or it increases revenue. So if you're just trying to optimize energy for a data center, I think it will be challenging. Where you can tackle energy optimization is grid optimization
Hmm.
in electricity distribution. That is an angle that you should look at.
Oh, okay, thank you. Okay, so maybe the good time to share the some demo that I talk about. So you have a good sense. What is it by the you have some specific problem, right? And then you want to solve using quantum, right? And then we here today have the expert to share a lot of things, but it may be better to just see the example, actual live learning, right? So. I will share my screen again and then show you some demo, right? Okay, share. Okay, so is it true that I mentioned that I'm very interested in I call it AI native quantum application. The AI quantum application means that actually that's what I'm doing. I'm doing my self experiment. Like as the you see that the applied quantum to real life problem is a very like sophisticated, like the workflow require and many expertise require. So it's a teamwork. So many know-hows required, right? But my point is to whether we can generalize this as a like as to the mass market approach that if someone actually provide some platform that sophisticated enough utilizing AI that like a Microsoft Copilot, right? So the human Copilot with this platform that I that's I exactly want. So I'm not successfully done. As I mentioned, I'm middle of the. I'm trying the real life problem in the energy management sector problem utilizing this infrastructure, and then the only party that involved this working is me, this platform, and agentic AI I developed. So this agentic AI is my co-filer. It support me to bring to this platform to work for the solve the real life problem. So I will disclose later if I successful, and I'm going to the submit a proposal to the big the E.ON, the European energy management company. But anyway, this is show you give you a sense about it. So where is that you have some specific problem you want to solve? Like for example, molecular ground status is a quantum chemistry problem. Whenever you do in, for example, the drug discovery, usually they go to a small molecular drug discovery. So you need to understand what kind of molecule the candidate for the drug. All right. So this is a fundamental thing you do. So I want to understand, calculate ground state of the molecular system using some mechanism like a variation quantum agent. So this is a this is like a simulator, classified as a quantum simulator. And that this is try to solve the, and then nature-wide is a quantum nature because of the underlying physics is governed by the quantum physics. So this is very fit into like how much we can utilize quantum computing to solve this real life problem. And then what it's doing is that it's a bunch of the agentic AI try to support you. So it just to try to understand what is your problem, right? So it from the starting for your problem, it tried to find out how actually can support you to bring this real life problem as can be solved by the so here is like it try to understand what your requirements. So whatever I choose it, and then but actually the I whenever you do actually the I supervise agentic AI to understand the problem and what kind of best way to actually formalize the initial problem. And then it tried to find out the solvers. So it can be like, for example, Genadi is a well-known like, quantum solver, or the Amazon bracket is some of the solver. And then so I would choose Genadu first, and then it tried to make a code to working on this Genadu the quantum hardware. So it can give me the chance to solve another opportunity. I can do it later in another quantum server. So and then it deploy, and then so you can think about a series of workflow supported by the agentic AI. So it's a traditional way is requires human expertise, a lot of the expertise required, and then collaboration. And then I'm trying to test it through this platform that me and then another agentic AI supporting me, and then this platform agentic AI system can actually solve the problem. So this is not the real world problem because this is a well-known and textbook problem. So this is just toy problem anyway because it'll give you the sense about it. And then it try to solve that, and then it find out the problem solution, and then it find out what the molecular energy it looks like that, right? So this is sense that okay. So and then maybe I will show you another one for example that maybe what is the good? Okay, so logist problem, all right? So in the logist, you want to find out optimal route to minimize your cost and then time, right? So you can have some specific industry from, like, for example, the logistics, and then in discuss with your intake agentic AI to understand what's your problem, and then try to convert to in the like mathematical models, and then find out the best answer. This is actually the optimization problem. Previous one is the simulation problem. So what they do internally is they do a quantum socket, and then try to find out the like optimization way to solve the like minimum agent solver. Here is a purely optimization problem, so you can sense about that. Fleet management is good, and then specify your requirement, and then it support you, right? So it look at all the potential possibility, and Groovy is a well-known traditional linear optimization model, and DF is annealing is a very optimal for the optimization. So I've select this D-Way. And then it's automatic healing, so it auto query about some of the problem with the code generation, and generate a code on the execution, and then it is solving over the some specific hardware, and then it find out the solution, something like that. Okay, so I have a chance to show just few. I have 100, and then I tested many different type of it. In the model wise, is working. For the real life problem, I'm solving now. So for the real life problem, it take a lot of effort, because of the all the human experts doing is I'm doing. So I'm the only human expert. But actually, I have a 3 years experience developing Showpiece agentic AI in healthcare life sciences. So I am very expertise in agentic AI development. So I develop my own agentic AI support this one. So another agentic AI, me, human expert, and this platform has a bunch of the different agentic AI to solve the workflow. And then if it's successful, whatever the successful is, it may be different meaning, right? It can be widespread over all different industry. That I'm not sure whether it's successful or not, because I'm still experimenting. But I on the halfway one solving the one's energy problem, and then I am going to apply to like I mentioned about the data center and other like finance, and then especially the in the drug discovery that I'm expertise. And then let's see. It requires more than 1,000 maybe experiments for me. But it's the beauty is that because I can do anyway, because spend my time, right? So it can be share something, right? Different, right? In the very short case pilot, and then bunch of the experts doing is one of the meaning, right? Valuable. Another meaning is that like me, do 100 different approach, but it's very quick way, right? To prove something, whether some real life problem can be solved in a quantum, right? So I will share later, but I'm spending a lot of time doing. So once I solve one problem, and then go to other problem anyway. Okay, so I think that we have only 6 minutes to have a Q&A. So if you have anything to question to specific speaker, or you have some comment, and then I welcome any comment and share from your audience side. Anyone?
At
It's a
least,
good time to you can share your insight, or yeah, Lago, can you share your?
at least there were a few questions on the chat which I think have been answered.
Uh-huh.
And let's see if maybe there is a comment from Randy.
There may be some ones that are like D-Wave is working on gate-based quantum process now. Yes, but not by their development. As far as they acquire some other company on working on the gate-based quantum process. So
No, they announced it on their own, right?
their own, really?
Yeah.
Their structure is a quantum analysis, is not the gate-based, right?
No, but they
As
have
far as I
announced a
understand
different
is
team.
that they acquire some company on the database quantum processors. So it's depending on anyway, because they own, right? Because they acquired then this theirs, right? Any question? Because recently, this is one actually that I'm whether I'm to share or not, but actually that I didn't that I just posted one time because recently there were a lot of the like quantum ecosystem is developing by the hardware vendors because once they are IPs and then they try to build up their quantum ecosystem. And one way is a Bodiker. So they end to end even the application layer. So they want like their own ecosystem application. So they like D-Wave is one of the active member, but another is a Bodiker. So they want to expand it to the other like modalities or something like that, or other application layer, something like that. So yeah, so I just want the clean summarization, right? But it may be more complex in the real life ecosystem wise, right? Because of this kind of like M&A and the expansion activities. This is I don't know about what are you doing to encode classical data into qubit? Do you know anyone? Nobody? I don't understand what is meant by the classical data. Data is a data, right? Because there is no any classical data or the quantum data, right?
Well, they are different. The quantum data is kind of totally different.
Uh-huh. Well, can you
So,
explain that?
so the because the quantum data is not just the zero ones, they basically the states, right? I mean, you carry states, right? There's
I
qubits,
see.
right? That's reason. So totally different. So most time you get a sensors, quantum data, you measure them, become class data. That's a problem. So actually,
Uh-huh.
people doing research like say, let's keep everything in quantum data. Don't come to classic at all. So that's a
Uh-huh.
new research. Actually, they say, okay, because all the data, sense data is actually quantum data because there's no right. It's not zero one. It's just different amplitudes. So
I
it's
see.
different.
I see.
The problem with the current computing here actually, they're doing here the problem with the quantum computing, the important here would be how do you load from quantum data or class data encoding to the quantum processor. That's hardest one. That's most
Mhm.
big problems. So
Oh, I
yeah,
see.
it's definitely different. I mean,
I
quantum
see.
data they're totally different. They're different.
I see. Thank you. Dave, actually, it's good time because we connected before, but actually, I tried to invite him as a speaker, but I haven't had a chance. So I know that you operate the Purdue University, one of the active university in quantum, right?
Oh yeah, okay. We most hardwares.
Uh, anyway, so can you share something that you're inside of what will be the future of the quantum or the quantum applications in view of academic side? I'm very interested in, okay? Because recently there are a lot of the academic side also, and then especially quantum hardware is all of the like nearly all of the like the quantum modality developers spin out from the university research, right? So you have any activities on the space or any kind of like do you are planning in Persia?
Yeah, for me, I most focus on the software because my background computer science.
Uh-huh.
So I focus on the quantum machine learning, the AI, now especially HPC, quantum AI together. That's the big thing there, right? So
Uh-huh.
if you look at the clinic, we work with the clinic. Remember the clinic they do the protein structures is huge. I mean, so most try to apply to the drug discoveries and something whatever have all these mechanics, right? I mean, all the proteins, the small structure there is hard to simulate with the classic computers, right? You want to use quantum computers, so that's the big thing here. So I try to help people. I'm not chemist, right? I'm not material science. I try to work people with the material science, chemistry, the clinical, try to figure how help with the quantum computing, QPC, HPC, help them develop new stuff. So
I see.
definitely the people in my colleagues in Purdue, they do some try to get better qubits, right? That's hardware side. like optic photonic qubits, even the way for the how do the transceivers from the, because when you send the qubits, right, you must from the spin qubits and qubit to the optic qubits again send over network, right? So that's a big thing there. Anyway, so there's so different. No one know anything, right? It's people just try the best.
How about have you any initiative working on the like a fault tolerance quantum computing development?
We have people do the QEC, I mean the quantum error corrections, I mean the ideas, the hardware stuff there. But that's my focus more software side. And so the if you look at the different standard, I mean if you look at from if you know there's NSF has a different standard for different areas for quantum computing. And then you look at if you look at look for the DOE, they have generous missions for AI for scientific discovery.
Yeah, definitely.
Now they also have they something called the quantum generous missions. If you look at the one, he's a Daria. Daria used to work at IBM. Now he's undersecretary from Department of Energy. He focused on the generous missions. And so if you search for generous missions quantum project, there'll be a lot of quantum stuff there.
Oh, thank you. Okay, so
Yeah.
so another good question. Maybe we can just touch this one and then we can finish up. So here's a question about regarding the hybrid decomposition workflow. When you hand off the master binary problems to a QPC, like OCA photonic system. Somebody actually talked about OCA right here. I think that how do you meaning the classical to quantum IO encoding latency?
So
Practice problem?
actually, so this project itself is not just only their real hardware. So we use their emulator and simulator. That's why it doesn't care on the latency with the real hardware between the QPU and the CPU at this moment. But for our next project in this year, we use their new real hardware product called PT3. Yeah, this is an answer for this project.
I see. Okay, so there are a bunch of things, but we have no time yet. So maybe we can have another opportunity because I regularly organize a webinar, and then I found that this topic is a lot of people are interested in. One of the most hot topic that I operating over this year every 2 or 3 weeks webinar, but I think that this is the most like people they get attraction. So maybe have a chance to do another, right?
Yeah, definitely. Yeah,
Yeah.
I want to contribute. Yeah, thank you.
Okay. So let's wrap up. So thank you. I think this is fantastic, and here and like you to share really fantastic insight about this one. And then participant as just post a lot of the question and comment here, and then David. Thank you for that. And then so hope to see you in my future webinar, especially next week. It will be very interesting about like fault tolerance quantum computing, what the status and what is the direction. And also like try to invite the industry speaker up to now, only one, but I welcome anyone to participate as to share your insight about what is the quantum the fault tolerance quantum computing. Right? It will be some different story that when we have that one, right? Contrast to the today is a limited power to provide and the full power provide what do you have, I don't know. Anyway, because it will be fantastic topic. Okay, thank you very much, and then I hope you have a wonderful last of the day. Okay, thank you. Take care. Bye bye.
Thank you for your arrangement.
Thank you all. Bye.
Thank you, everyone.
Bye.